Hello, everyone. Good afternoon and good evening, and good morning, depending upon from which part of the world you are logging in. Welcome to this new session on one-click deployment using GitHub Actions for Digit. My name is Vibhor Bansal. I manage partnerships at eGov, and with me is Nikhil, who is a senior tech lead at Digit, and he will be showcasing how you can how we have simplified the Digit deployment using GitHub Actions. And this will be about an hour-long session. The couple of things that I would like to mention to you is if you have any questions during this session, please put in the Q&A tab. You can also interact with us over chat, but I would suggest that your questions should be in the Q&A tab, and our respective teammates here can respond as the session flows. If a question is directed to Nikhil, he will respond as and when he feels time is right. We'll try to keep about 5 to 10 minutes in the end for any question on further questions and answers. And please utilize this to the maximum, share with your colleagues, and that's it. I will not take much of the time. Hand it over to Nikhil to take it from here, and let's start. Thank you.
Yeah, thanks Subodh for the introduction. So, hi everyone. So, Nikhil here. So, I work as a senior DevOps engineer here at eGov. So, I'll just give you a brief overview on like why we have chosen GitHub Actions for Digit deployment and what are the advantages that we have and what is the time that we save like using GitHub Actions for Digit deployment. So we are even releasing Digit 2.9 as long-term support version. Okay, so that would be released in like it'll be released in like 2 to 3 days. So where you will get a chance to deploy this digit using GitHub Actions. This will be a one-click deployment. I'll just walk you through. We'll start with the installation process once. Okay, and then while the installation is going on, maybe I'll walk you through the approach that we followed and what are the steps that are happening in the deployment process, and what further improvements that we are going to bring in. Okay, so that would be covered in this session. I'll just share my screen one. I hope the screen is visible, right? Yeah.
Right.
Okay. So for the main reason is why we are going with the GitHub Actions is that it's completely integrated with GitHub. So you don't have to spend time, configuring CI/CD setup. Like you don't have to have your Jenkins installed and then bring your digit code there and then start deploying it. And it's completely integrated into GitHub. You just have to make few settings. So just you'll be providing the cloud credentials. So once you provide few input parameters, you will be able to deploy Digit into AWS environment. And like we have many custom multiple CI templates that are readily available. Like you can just easily integrate into your GitHub Actions workflow. Okay, so like in Jenkins, you will have to worry about maintaining it, and then configure. Bringing your own server. Okay, make sure that the plugins are always up to date. Okay, but with GitHub Actions, you have free runners where you can run your code on the free servers or you can always go to a if you have your repository as, if you configure it as private, you can have like 2000 minutes per month. And if not, you can go for the self-hosted route. Let me just give you the, I'll share you the repo access. I'll give you the repo details now. Can anyone of you share the repo link in the window? Okay, so if anyone wants to try out the one-click deployment process, they can use this particular repository. They can fork the repository and then they can deploy it. So we have provided the installation guide and all the setup instruction and all the setup steps that you will need to follow. I'll just walk you through this process. So let's start first with creating an I mean, we already have an IAM user already configured. So please make sure that when you are using this IAM user, it will, the IAM user should have an administrative access. Okay, so only then you will be able to deploy all the resources that are required for Digit. So once you have configured IAM user, you have to provide these credentials in the settings section of your repository. So where you will be able to provide your access key and secret key details. So you can just go to the repository settings and then the secret settings. There you will have to provide these values: AWS access key ID and AWS secret key ID. And you have to configure these variables, the AWS default region variables. So now that you have configured it, you'll have to provide a few input parameters. So to provide those input parameters, you have to navigate to the input.yaml present in this particular path. So here you will be providing the details of the cluster name and the SSH key that you will need for the pods to fetch the code from GitHub. And you will be providing the DB name and DB username and what the domain name on which you wanted to access Digit. And here you will need to provide the information of Terraform state bucket name as well. So here, why Terraform? So we are providing Terraform state bucket. Why you have to provide the Terraform state bucket name is that since we are creating the infrastructure via Terraform, the entire configuration will be stored in a state file. Okay, so which would be placed in an S3 bucket. So anytime you want to make changes to your Digit infrastructure, you can just pull that state file, and then you can always get those changes applied, and so that you will have your infrastructure consistent. So now I'm going to provide these details here. So I'll be providing the domain name as githubactions.digit.org, and let me name the state bucket name as digit-GitHub actions. So once you provide this input, these parameters, you will have to provide two secret values. So to provide these secret values, you have to navigate to deploy as code, charts in the environment, and here you'll find the dev-secrets.yaml. So where you would be providing the password values. So these password values is the DB password and the flyway password value. So these are the credentials that the applications, the pods would be using to connect to the RDS database. So I'll be updating these two values, and here we'll be providing the these input values. Now that we have provided these values, all we have to do is we'll just commit this repository, commit to the repository. Okay, so now that I have committed these changes, you can see how the infrastructure process is getting created. Okay. So you can click on this actions tab. Okay. Now you will be having 3 jobs. So one is an input validation job. The other one is Terraform infra creation process, Terraform infra creation job, and the other one is digit deployment. So the first job, input validation, it validates whatever parameters that you have provided here. Okay, we have some code validations that are enabled, so that if you have, if you provide certain value not according to what AWS recommends, so your input validation job will fail. And once your input validation job is successfully passed, then only your subsequent jobs will get triggered. So now we have the Terraform infra creation job and digit deployment job that will run in next. And so in Terraform infra creation, you will have all your Terraform commands that will be running here. Now I'll tell you how exactly, this Terraform infra creation, it is going to take some time. It might probably take around half an hour for the infrastructure to get created. So while this is happening, I'll just walk you through how GitHub Actions works. Okay, so how did we set this up? Okay, so what are the key terminology that that will help you in probably having your own customizable workflow. Okay, so that we will be covering now. So this is the the main components of the GitHub Actions is that first is workflow, and the second one is the event, and these are the jobs. Jobs you can consider it as you have the step of instructions or the step of commands that you can run. Okay, that you can classify, that you can configure it as per your requirements. Okay, and you can have multiple actions for your repository, and these actions you can literally borrow it from different marketplace providers as well, or you can write your own actions. And runners are the VMs where you run your respective jobs. So every time you click on a job, basically a container would be created, which would be following whatever instructions that you have provided in your steps, and these would be executed, and then the container gets destroyed. So more like you can understand it as an it's a Docker in Docker sort of concept. Okay, where it actually creates a container, and then all your all your steps would be created in that particular Docker container. And once the job is done, they would be terminated. I will show you where exactly this is configured. So you will have to navigate to this particular .github folder, and we have digit underscore install.yaml. Okay, so where we have provided all these GitHub Actions workflow. So right now we are defining this workflow, and we have discussed the term events, right? Currently in this particular workflow, we have configured the workflow to get triggered on only push event, and push event that too on when the commit happens to the master branch. Okay, let's say you wanted the pipeline to trigger on like a different branch. You can always modify the branch settings here so that you will have the pipeline getting triggered on different branches as well. And so these are the respective jobs. So since we have like the three jobs, input validation and the Terraform infra creation jobs, right? So they are I mean these are how they are set up here. And here you would be providing, the cloud credentials. Already they are provided as secrets. So we are just fetching those values into these environment variables. And here we are using Ubuntu latest as the runner machine. Okay, it's a freely provided virtual machine by uh, GitHub itself. So we don't have to worry about it since our repository is publicly available. And now the next one, the next next event would be the steps section, where you would be providing the respective commands. So you please make sure that this would be and the entire GitHub Actions workflow syntax is in YAML format. You don't have to like write a custom custom scripts to manage your deployments. You can see, just to get the code, you can use this particular action item. So now just to clone the code, we are using actions plugin. Okay, so which would fetch the code from the GitHub onto the server, and then we can execute the further steps as well. And now to validate the inputs, right? So we are using a plug. It's an action. It's an action item. Okay, so where we are, this particular action item, this particular action, it would fetch the input.yaml, and then it would convert into environment variables, and that can be utilized across your entire pipeline. Okay, so this information would be available. Since it's stored as an environment variable, across the entire job, you will have, you can make use of that particular values. And so we have an script that updates all the input variables that would be updated across the entire either Terraform and then respective Helm templates also. So this is the rough overview of like how GitHub Actions works, like what are the components that it is essentially made of. Okay. So anyone is like free to add their custom. If they wanted to deploy any other, if they wanted to add any unit tests, or like they wanted to validate their code, they can configure it. They can add an extra job here. Okay, and then they can run it as part of their deployment process. So just so the Terraform infra creation it's going to take around like half an hour. So it's still in progress. So the next item that we plan to, what we plan on changing in our deployment process is that earlier digit used to be deployed using an Golang script. So basically, this particular script would be fetching all the Helm charts. Okay, based on the based on the version, it would be deploying it. But now we will be going with an Helmfile approach. Okay, so the reason why we are moving towards Helmfile is that so our previous we had a lot of community projects. They are so they wanted to incorporate their applications into Digit Stack. So we had certain challenges, maintaining the Go deployment script where providing the adding a new Helm chart was particularly not easy. Okay, so we wanted to incorporate Helmfile into our Digit deployment stack, so that like you can literally fork your open source Helm charts. You can add it into your Helmfile, and you'll be able to deploy it without any hassle. So one thing is we wanted to standardize the Helm templates. Like couple of users, they wanted to change namespace of the particular services into a different namespace. Okay, so using our Go deployment script, we had to do multiple changes to enable that. So now we are going to solve Helmfile. With Helmfile, this problem would be like easy, and you'll be able to solve it. You'll be able to deploy it to different namespaces, and you can customize it as per your requirements. And we were not completely utilizing Helm capabilities as well. Like, so let's say once you have deployed your digit cluster, if you wanted to see what are the releases that you would be deploying, you will not be able to get get that information using Helm binary. So with Helmfile, you can get exact information of what all Helm charts are being deployed, and so you can like fully execute all the Helm commands into your digit stack. So let Helmfile, you can. So one of the main advantage with the Helmfile is that so it basically works like a Terraform itself. So in Terraform, you just have a state file where based on your state file, your entire cloud infrastructure would be managed. So whenever you wanted to see if particular resources, if it belongs to this particular state file, or if it is created beyond out of the state file, like similarly, you can use Helmfile to manage your Helm charts. You can like literally have complete Helm charts and then have version control maintained. You can periodically check if your Helm charts are in sync with whatever is deployed in your Kubernetes cluster. Let's say like there wasn't any manual change in your Kubernetes cluster. Okay, like running all the Helmfile commands, with you will be able to you'll be able to identify what manual changes that are being done in your cluster, and you'll be assured that your whatever is there in your Helmfile, that is exactly in sync with your Kubernetes cluster. So I recommend you go through the Helmfile documentation once. So still infra creation is going on, but I'll show. In the digit deployment phase, right? You will actually see we have. Your digit is being deployed via Helmfile commands. So now you can see, right, in the workflow actions file. So we have created, I mean, we'll be running this helmfile hyphen f digit hyphen helmfile.yaml apply. Okay, I'll show you how we have created the helm file. Okay, and how you can actually add a custom helm chart. I mean, add a helm chart into this particular helm file. Uh, let's say in digit, right, we have different category of services. Like we have auxiliary services, we have, I mean, the main backbone services and the core services. Okay, and the monitoring services. So for each, I mean, let's say we have I mean, these are, you can consider it as these have been categorized as part of product. Okay, so for each particular folder, like for the backbone services, we have one particular helm file. So for backbone services, we have one backbone services hyphen helm file, and for core services, we have one more helm file. And so for monitoring, we have the monitoring helm file here. Okay, so this is the basic structure of the helm file. So where you first you will have to provide which particular open source Helm charts that you would actually using. So for monitoring stack, we are using the Helm charts from Grafana. Okay, so we are providing the the Grafana Helm chart value. I mean the repository URLs, and we would be providing the, I mean, you will have to just mention releases. So that will comprise of, I mean, that will give you, I mean, whatever, if you wanted to deploy multiple Helm charts, right? You will just add it here. You will just name it as, like we want to deploy Loki stack. You'll just name it here. And then you'll be providing the namespace parameter. And then you can have your own, I mean, you can, let's say you wanted to deploy different versions of Helm chart, you can just change it here. And you can provide what values.yaml that it would be picking in. I mean, if you are not going to provide any, I mean, values.yaml like default, it would be fetching whatever the default values.yaml that the Helm chart community is maintaining. That would be provided, and your installation would be enabled this way. So whenever, I mean, once you have this Helm file, right, all you have to do is just run Helmfile -f and sync. Okay, so all your Helm charts would be deployed. I can, I mean, give you a like better overview of when the deployment process is actually happening, where you will see how Helmfile command actually works. So you can, I mean, you can always go through the Helmfile documentation. Uh, So you can just consider Helmfile as just a binary. I mean, it basically uses Helm as the binary. Okay, but it is just a wrapper where you can like literally orchestrate multiple Helm charts deployment instead of having your own scripts to deploy Helm files, or you can, having multiple umbrella. I mean, creating an umbrella chart structure. this would be a simpler way to deploy multiple Helm charts. So like it's very much scalable. There are use cases where people have been deploying around 600 to 700 Helm charts just by using Helmfile. And if anyone wants to try out installing it, I mean, let's say once your cluster is ready, right? You can always, you know, get your Helm file, okay, and then run. I mean, once you have Helm file binary installed in your local machine, you will be able to, deploy multiple Helm charts using this. So before, I mean, I was telling you like the Helm file has the capacity to, check the cluster state, right? Like whatever the state, I mean, whatever the state file I mean, you can just consider Helm file as the, I mean, pseudo version of Terraform state file. Okay, so if in order to validate how Helm file is exactly syncing the cluster, you can use the Helm file sync commands. So whenever you run the Helm file sync command, right? It will just read the values from the Helm file, and then it will, I mean, it will, every Helm chart that when you create it, it would be created with particular annotations. Okay, so that will make sure that your Helm chart, your application is managed by Helm. Okay, so what Helm file does is that when you run Helm file sync command, it would identify the particular annotations, and then you can, it will evaluate. It will check the entire configuration. Okay, whatever that is provided in your state file, and then it will evaluate with the configuration in your cluster state. So if you are initially creating the cluster, if you are initially running the Helm file for the first time, please make sure that you will use Helm file apply command. Okay, and going after, if there are, if you wanted to check the state of your Helm charts, then probably you can run Helm file sync command. Okay, but when you are initially creating the Helm chart, when you are deploying Helm file, please make sure that you run the Helmfile apply command. So what Helmfile apply command does is that first it will run Helm template command in background. Okay, and if the diff plugin is installed, it would fetch all the. It would check the cluster state. Okay, and then it would get the required manifest data, and if it finds any difference, it would be sort of applying the differences. Okay, and if you want, you can always have dry run also before you wanted to apply this Helm file. Okay, if you provide the -- dry run parameter, you will be able to do it. And earlier in Digit, it was not easy to delete the Helm chart. You will have to sort of use the script again, and then or to delete, you would have to run the Helm template delete command. But with Helm file, it is easy to delete your particular Helm chart in the cluster. All you just have to run is provide the Helm file and then run destroy command. Okay, so basically it it identifies whatever the label identifies the labels in the cluster, And then so it would be deleting the applications which are managed by that particular Helm file. So before you provide, I mean, if you wanted to provide any interactive parameter while destroying it, you can just use Helmfile interactive parameter so that it will request your confirmation so that any accidental deletion would be, that could be avoided. Let me check once if the deployment process is, if there are any issues with the deployment process. Okay, we are still in, it's in still Terraform infra is getting created. Okay. Okay, so our Terraform infra creation is successful. Okay, so now the digit deployment is happening. So in the deployment phase, so whatever code that that we have provided in the deploy as code folder, right? That gets executed. All the charts are provided in the deploy as code section. So these charts would be deployed, and we have our main digit Helm file. So the Helm file is actually running this particular digit Helm file, which in turn looks for different Helm files in this particular folders, and then it will start deploying different charts. And if someone wants to add their own Helm file chart, they can just provide their respective path here, and then they can straight away start deploying it. Okay, so since we have, since the deployment is going on, right? I'll show you how to access the cluster. So I already have AWS credentials configured in my machine. So you can just use the profile. You export the profile and then generate the kube config. Okay, so this kube config is getting generated. Yeah. Now when I run the kubectl get nodes command, right, you will be able to look at the nodes that are being created. So as part of 2.9 LTS, we have updated the Terraform code, and we will be providing the resources. The Kubernetes cluster would be launched with 1.28 version, and so basically the entire charts are being updated, and even the Java version is getting that is also being changed. Okay, so you'll have entire digit running on the latest version. Okay, so that will be supported like, so we intend to support it for almost 5 years. So that's how. So and when so then the next deployment process would be utilizing this particular workflow. Let's see the status of the pods. Okay, so they're still getting deployed. So we have these three jobs, right? One, check changed fails and digit only deployment and Terraform infra destruction. So the main reason that we have added these three jobs here is that, let's say once you have installed digit and you don't want to make any changes to the infrastructure and you just want to, change, the particular charts. Okay, you wanted to update the image versions, or let's say you wanted to update any only deployment related configuration, not Terraform related changes. So this particular check changed files job, this would actually evaluate, uh, I mean, on which particular folder the changes are made. Okay, and it will make sure that only the respective job gets triggered. Let's say you have made changes only in the digit only deployment section, like only in the deploy as code category. Okay, so you will, I mean, your Terraform infra creation job, it will not be triggered. Only the digit deployment job will be triggered. And now that you have created the entire cluster, let's say you wanted to destroy it, or like you wanted to install it onto a different account, Terraform infra destruction job, it would, I mean, it will be very much helpful to entirely clean up your infrastructure. Okay, so I mean, once after the installation is done, right? I'll show you how I'll show you how the Terraform destruction job works, and how you can like completely destroy the infra that you have created now. Okay, now you can see, right? This is the digit deployment section. So this is where the Helmfile command is exactly running. So once you run the Helmfile apply command, uh, so it is generating, it is basically running the Helm template command, and then it is generating all the manifests that which are going to be applied in the cluster. Okay, so this we have made sure that first the backbone services would be deployed, and later on the core services would be deployed. So that like, if any particular application is very much dependent on the backbone services, right? Okay, they are made prioritized first, and you can see the respective chart related instructions as well. Like if you wanted to, here we have Minio. If you wanted to, get the credentials, you can run these kubectl commands in your Kubernetes cluster, and you can make use. You can use this particular service. And for Kafka also, right? Since we are deploying Kafka as a pod, we are providing Kafka as a pod in Digit. You can run. You can run these particular commands to evaluate if your Kafka cluster is healthy or not. To make sure that your your producer messages are sort of being pushed onto your Kafka cluster, and then you can verify the health of your Kafka cluster, and then you can run these commands. So all these would be provided. Uh, when you are deploying via Helmfile. Okay, and so now we have our monitoring services getting deployed. So these are our last batch of services. So once these are deployed, right, we'll have our entire Git stack ready. Okay, so our deployment is successful. You can see, right, all the steps that we have provided in the GitHub Actions workflow file, they got executed. And here you can get the information of the load balancer ID. So if you just can, if we map this particular load balancer ID to your in your DNS provider, uh, you'll be able to access the GitHub Actions UI. Let me pass it on to my teammate. So, okay, so it is being added into our DNS provider. Let me quickly check if the DNS is propagated. Okay, so now you can see that the DNS is propagated. Let me check simultaneously if the certificate got renewed as well, and the certificate has created. We are using Cert Manager, which would create a Let's Encrypt certificate, which lasts for like 3 months. And then the Cert Manager will automatically renew after every 3 months. Okay, so the certificate is still getting generated. Okay, let's wait until the certificate gets generated. Once the certificate is generated, sometimes it takes time actually. The cert manager will have to make a call to the DNS server, and then like the server will have to do the validation. Okay, sometimes it would take some time. So once the certificate is generated, probably you'll be able to view the UI. Okay, now we can see the health of the pods which have been deployed. Like everything looks fine. Like all are deployed. Okay, now you can see, right? The certificate status has changed from false to true. So we can check the UI. Okay, so that's how we can access. So basically, we just provided some 5 to 7 variables, and then just after providing the cloud credentials, we were able to deploy Digit. Okay, so like whatever the time that we have spent earlier we had to set up, we had to make sure that we had to install Terraform, we had to install kubectl, we had to install Helm. Okay, so all that process uh, could be avoided, and now like you can install. I mean, the time to install digit has like uh, we have managed to bring down the time now. So now that we have created the cluster, right? I'll show you how this particular cluster I mean, this entire resources can be destroyed. So if you come to the workflow section, and if you come to the run workflow section, so as I mean, the moment you run, I mean, if you enter destroy and then run workflow, your entire the cluster, I mean, the entire resources that you have created, they would be destroyed. So this is sort of like you can have digit installed like in very few minutes, and then you can make use of it, and then you can terminate it, okay, whenever you want it. Okay, so that is one of the main advantage of using GitHub Actions, for installing digit, and then for going forward for managing digit as well. Okay, so in the upcoming sessions as well, like we plan to provide the deployment scripts for each individual service, so that you don't have to have your own custom Jenkins and then manage it. You can just we'll be providing one custom CI template that you can make sure that you can make use of it, and then make changes to your application code, and then you can deploy it faster. So, I mean, if you guys have any questions, we can probably. But do we have time for questions? Okay, let me know if you have any questions.
I see a question in the window. I think Naresh is responding to it. So, folks, I think we have completed this session about well in time. So if you have any questions, we can take a few. You can either write it in the Q&A. That will be the best way to respond. So we'll wait for, say, about 2 minutes. If we don't see any questions coming in, any queries coming in, I think that will be a sign we sign off. Nikhil, you can check out. There are a few questions in there. You want to respond live?
Yeah, hi. So the CI/CD for each microservice is not part of the session. Okay, so we'll be covering it in the next upcoming session. So as I told you, right, we'll be giving you one custom template. All you have to do it is add it in your repository, and that will take care of your each service deployment. So this is for entire digit stack deployment.
Yeah, Nitin, actually, Digit is cloud agnostic application. Okay, we don't have any dependency on other clouds. Right now, we gave demo to the complete overview from how to create infrastructure, later on how to deploy Digit on created infrastructure. That's why it is taking time. So we are coming up with the Helmfile that can give you freedom, whatever the required services you want to deploy into your existing infrastructure as well. And also we are providing additional services like, okay, if you don't have any changes within your infrastructure code, it will able to deploy whatever the changes you have made into the your Helmfile. Those changes will also deploy, but that's why we choose GitHub Actions that is giving additional beneficiary for the continuous CI/CD.
So we don't have Azure ready GitHub action script yet, but we are going to provide it in sooner. So for now, if you want to, use it to deploy in Azure environment, right? You just make changes. So I'll show you in the code. So once you, be it any cloud environment, once you have your cluster ready, all you have to run is these two, this particular one step, like the line 398 one, Helmfile, and then you run, you apply the digit Helmfile. Okay, so that will take care of deployment in any cluster. So we don't have Azure ready deployment script now. But our older version still works. So, do we plan to release it in the future? Yeah, we plan to release it on Azure as
So I just confirmed folks were interested in Azure. There is a plan to release it in future, but we'll keep you guys posted. Oh. Yeah. Okay. Thank you. Thank you, everyone. I hope you all found this session helpful and you will use it more frequently. You know that you can always write your queries in our discussion board on GitHub, where a team at Digit would be happy to respond, and maybe you'll get the responses as soon as possible. Thank you. Thank you for joining us. Till we see you next time. And we'll keep you posted on the upcoming sessions. Thank you.